Yeah. Hello guys, welcome to my channel. So in this video, I'm going to discuss about some of the gate important topics. So this topic is for COA subject IEEE 754 floating point data representation. So this is very important topic for exam gate examination point of view. Okay. COA subject IEEE 754 floating point data representation. Floating point data representation. So here I'm going to discuss about some of the previous year questions, okay, and some concepts. So in floating point data representation there are two types. One is single precision. One is single precision floating point data representation, and another is double precision. Double precision floating point data representation. So in single precision, like sine, sine is 1 bit, exponent, okay, that is 8 bit, and fraction part, that is mantissa, so that is 23 bits. So total it is a 32 bit data representation. So similar to that, in the double precision data floating point representation, 1 bit for the sine, and for exponent part it is 11 bit, and the fraction will be 52 bit. So 52, 53, 63, 64. So total 64 bit data representation. So here now I'm going to take one number. Okay, so here the previous year question is there. So here the following bit pattern that represent the floating point number, that is IEEE. So here they are given the 23 bit. Okay, here they are already given the this particular already given the 754 single precision format, and that value is 26. Okay, so here I'm here actually in the question already they are given, a data. So this 32 bit, so they are given, and we need to find out the corresponding decimal value. Okay, so now I will do in a reverse way. So actually the answer is minus 26. Okay, now I will convert this number. How we can convert the decimal to binary, that is in a single precision format? How we can convert the decimal number to single precision format? Okay, single precision floating point format. Now find out the binary for the 26. Okay, so this is 111010. So that is the binary. Okay, now here actually this is This is 26. Okay, plus 26. So include the 0, double 1, 0, 1, 0. So let us take the 2's complement of this. Yeah. So here like plus 26. Okay, so here they asked the given number is minus 26. So sign is negative. Okay, the sign is negative, so that is 1. Now if I represent this in a single precision format, sign is this one, sign is negative. Like here I will just put it in a box sign, and here will be 8 bit of exponent, and there will be 23 bit, 23 bit for the fraction part. Okay, sign. So sign is so here this is for the 26. Okay, now what you have to do, you have to convert this into a normalization form. So normalization form, 1.1010 into 2 raised to 4. Okay, so this 4, and we add 127 for the bias value for single precision, so that is 131. And if I find the binary for 131, so just I will use the calculator. So here it is, binary is 15011. Okay, and the fraction part is there. No, fraction part is 1010. So total it should be 23 bits. Okay, so this is 1 bit, 8 bit, and remaining 19 bits. 19 bits you have to make it 0, 8, 12, 16, So this is total represent. So here you can just compare this with this value. See, this is the sign, and it's 1 5 times 0 1 1 and 1 0 1 0 and remaining. Means in this case I have just reversed them. Actually in the examination what they given, in the examination they are given that you have to convert the single precision floating point format into the decimal form. Okay, so now just now I have shown in a reverse way. I have taken the minus 26 and converted into the a binary single precision format, single precision floating point format, floating format, that is 32 bit, right? So here now I will show in a reverse way. A reverse way means now in this way. Okay, now this data is there now. So okay, so this particular data, so this here you understood. I hope it is clear. Now I will take that binary value. Binary means whatever they given. Okay, so this is the value they are given. Now you have to convert this number into binary, yeah, decimal value. This floating point to decimal value you have to convert decimal value. Now you know the sign is this is the sign and this is the exponent part. Okay, this is the exponent part, and this is mantissa part. Okay, sine, exponent and mantissa part. Now like to convert into the decimal form. Okay, so sign indicates it's a negative number. Okay, it is a negative number, and the exponent, so 1 triple 5 times 0 1 1. So what is the decimal of this? 2 raised to 0 into 1 means 1. 2 raised to 1 into 1 2. So 0 into any number will be 0, and 2 raised to 7. So 2 raised to 7 means 128. So this will be 131. Now this is the decimal value we got, and here we have to subtract the bias value. What is the bias value for the single precision? That is 127. 1023 for the double precision. So now how much value we got? 4. Okay, so that is the decimal value, means for this exponent. Now 4, we got the value 4. So here just write down, this is the binary for the 4, and this we can normalized form, we can write it like this is equivalent to this one. Okay, no, there is no difference here. Okay, so 1.00 into 2 raised to 2, so that is equivalent to this number. So there is no difference between these two numbers. Okay, now see here, Okay, so 127 bias value you have to subtract, then the one before the mantissa. So here the normalization form. Yeah, sign will be there, and the exponent bit, this is the 2 raised to 4. Okay, so sign will be there, and here in this particular case exponent, what is the exponent value? 101. Okay, see, your exponent will start, this is the exponent value 101. Okay, sign is there. Okay, so normalization form is 1 point this fraction part into 2 raised to 4. Actually we have to keep, this is the exponent value. Okay, so this is the exponent value, because in the earlier case while converting the river we added the 127 to 4. Okay, now it is reverse. Okay, so 1.104 into 2 raised to 4, 2 raised to 4, this is the value. And now you can convert that exponent part, like one decimal digits, you just shift 101, 3 digits, 4 digits. Okay, now this is in a binary form. Okay, now just check it out, what is the decimal part of this? 2 raised to 0 into 2 raised to 0, 0, 1, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 4. Okay, 10 26. And this particular sign indicates it is a negative one, it is a negative number. Okay, so we got the minus 26. So in this video we discussed about single precision format and how we can convert the given single precision to decimal and decimal to single precision. Okay, thank you.